Hello there dear students, welcome to my channel. Okay, in this video I'm going to explain to you about chemistry paper 4, 43, October, November 2020. The duration for this paper is 1 hour and 50 minutes. Okay, let us continue with the first question. Okay, first question. The names of 9 substances are shown. Okay, here we have a 9 substance. Okay, answer the following questions using these substance. Each substance may be used once, more than once, or not at all. Okay, name the substance that is the main constitution of hematite. Okay, if you see a hematite here, it should be iron oxide. Okay, iron 3 oxide. Okay, look at number 2. A gas produced in car engine which causes acid rain. So here should be your best answer. Here will be nitrogen dioxide. So you will combine with water to form a nitric acid over here. Okay, now let us look at the C, an alkaline gas. So this is acidic. So your best answer here will be ammonia. Okay, now let us look at D, an element. They are asking for an element. So element here will be, if you look at steel, it is an alloy. Okay, it's a mixture. It is not an element. So your best answer here will be silver. Silver is Ag. Okay, argentum in our periodic table. So we can write here silver. Okay. A gas formed by the incomplete combustion of fused cell. So here should be carbon monoxide. If let's say you have a complete combustion, it must produce carbon dioxide and also water. Used to test for the presence of water. So if you have this, your best answer here will be under anhydrous. Okay, anhydrous cobalt 2 chloride. And also please remember the color of this. It will change to blue to pink color when exposed to water. Okay, please remember this part. Okay, this is for question number 1, 6 marks. Now let us go to question number 2. Okay, number 2, the table gives information about the 5 particles A, B, C, D, E. Okay, this is electron number, neutron number, and proton number. Now state the atomic number of A. Atomic number of A. So atomic number is proton number. Okay, so remember atomic is a proton, and if you have mass number here, it will be under nuclear number. So this is a proton, so it's 11. Okay, state the nuclear number. This is mass number. Alright, mass number. So for B, so mass number will be calculated by proton plus with neutron. So proton plus with neutron. So 20 plus with 18, you will be getting here about 38. Okay. 38. Okay, C. Write the electronic structure of C. C here we have 18. Let us check this. Proton 18. So it will be 2.8.8. Okay, now look at the next question. Okay, give the letters of all the particles which are atoms, positive ions, negative ions, and also isotopes. Okay, now let us go through one by one over here. Okay, now if it is an atom, both electron number and proton number must be the same. So this is atom, this is also atom. Now look at the last one, the E, this is also atom. Okay, now here the proton number is 11 and here's 10, so positive is one more, right? So here will be A plus, so will be positive ion here, positive ion. And look at D, you have a more electron number by 2 compared to proton. Okay, so here will be D, and the ion here will be 2 negative, so this is a negative ion. Okay, now they have asked about isotope. Isotope, the meaning of isotope here will be, okay, the isotope here will be same proton number but difference in neutron and also nucleon number. Here will be the difference. Okay, now let us look at the same proton number here. So here we have 18 and 18, so B and C, they are the isotopes. Okay, they are the isotopes. Okay, now let us answer this question. So now they have asked atom. So atom is, we can say B, C and also E. So we just write it down over here, B, C and E. Okay, positive ion and negative ion we have only one. The positive is A and negative is D. So we write it down here, positive is A and negative is D. And isotopes, as we discussed just now, so we have B and C isotopes. Okay, so this is for your question number 2. Let us move on with question number 3. Okay, number 3. This question is about nitrogen and some of its compound. Complete the dot and cross diagram to show the electron arrangement in a molecule of nitrogen. Okay, show the outer shell electrons only. Okay, now let me zoom this bigger. Okay, now if you notice that the nitrogen has 7 electrons, so the electron arrangement here will be 2, 5. So let us draw the Lewis structure here first. So let's say I just draw here the cross 5 and I draw another nitrogen with a dot. So here we can see there is a triple bonding, 1, 2, 3, and this nitrogen, it has about 8 electrons, and this nitrogen also, they have about 8 electrons. So inside here we have about 6 electrons sharing. Okay, so we can use this model to draw the dot and cross here. So here we have 3 cross. Okay, now we go for the next one. Here we have 2 dots. So 1, 2 and 3. Okay, so this is your answer. Okay, let me zoom out. Okay, now this is triple bonding. Okay, now let us move to the next one. Okay, here. Okay, B. Nitrogen can be converted into ammonia by Haber process. Describe how nitrogen is obtained from the Haber process. Okay, so here in our air we have 78% of a nitrogen gas. So they will liquefy the air, okay, to make it as a liquid. Then from the liquid they will do fractional distillation to obtain a pure nitrogen liquid. Okay, so I'll present my answer now. Okay, so this is my answer here: fractional distillation of a liquid air. So it has been it will be separated by different boiling point compared to the other gases. Okay, now let us look at number 2. Give the essential reaction condition and write a chemical equation for the reaction occurring in a Haber process. So Haber process, you will have hydrogen and nitrogen, and they will form ammonia. Okay, so when we balance this, we will be getting nitrogen is 2, so we put here 2. So hydrogen will become a 6 atoms over here. So here we have to put a 3. So the ratio here will be 3 and 1. Okay, so the reaction condition, just remember, we have to put the pressure, the temperature, and most importantly is the catalyst. Okay, so the pressure over here will be about 200 atmospheric pressure, temperature 450 degrees Celsius, and here will be iron. Okay, iron catalyst. Okay, so please remember this. Okay, see, some of the ammonia made by the Haber process is converted into nitric acid. This is called as the Ostwald process. Okay, this is called as the Ostwald process. Okay, the first stage of this process is the oxidation of ammonia to make nitrogen monoxide. Okay, the process is carried out at 900 degrees Celsius, a pressure of 5, using an alloy platinum and rhodium as a catalyst. Okay, the forward reaction is exothermic. It means it is releasing a lot of heat. Okay, so catalyst, the word catalyst is same like an enzyme. So state the meaning of it. So it's a substance where it speeds up the reaction. And remain unchanged at the end of the experiment, or you can put there at the end. Okay, state the meaning of the term oxidation. Oxidation, you can say loss of electrons. Okay, loss of electrons, or increase in oxidation number. You can also say gain in oxygen. Okay, now we move on with the next one. Okay, now here at this part, complete the table using the word increase, decrease, and also no change. When you increase the temperature, remember the process here is exothermic. Okay, it means the reaction is already releasing a lot of heat. So what happens if we increase the temperature here? Effect on the rate of the forward reaction and effect on the equilibrium yield of nitrogen oxide. So nitrogen oxide is the product here. Okay, so here will be the rate. Yes, they do increase, but they will decrease in the yield. If you increase the pressure, both will be, here will be increase and here will be decrease. Because if you notice the pressure that they use for this experiment here is only 5 atmospheric pressure. Okay, so if we increase the rate of the forward reaction will be increased, it means they are pushing toward the product, but the product yield will be reduced. Okay, now when we look at the D here, nitrogen monoxide is converted into nitrogen dioxide. Nitrogen dioxide reacts with oxygen and water to produce nitric acid as the only product. So they already mentioned here what we should add in the equation. So we just have to put NO2 as a nitrogen dioxide. They react with oxygen, straightforward, and water. Okay, and they also mentioned nitric acid as the only product. So this is the formula for nitric acid. Now our work is only for balancing. So we have here oxygen, we have here 3. Okay, so here we have 1, 2, so it becomes 3, so it's 5. So if it's 5, let's say we put here 2, and the hydrogen becomes 4. So if here we put 4, hydrogen is 4, and nitrogens we add on here 4. Okay, now the total oxygen here will become 8, a 2, and a 2. So total up we have 12, and the total oxygen here is 12. Yes, it is already balanced. So this is your answer. It's 2 marks. Okay, now we move on with the next one. Okay, so this calculation here, ammonium nitrate, okay, wait, let me make it bigger. Okay, ammonium nitrate is a fertilizer. Calculate the percentage by mass of nitrogen in ammonium nitrate. So we need to calculate the whole thing here. So here's 14, here's 4, here's 14, and here's about 16 times with 3, we are getting here about 48. So we plus all, the total we are here getting about 80. Okay, about 80. So total is 80, and the nitrogen we have 2, which is 14 plus with 14 we are getting here about 28. So multiply with 100. So we are getting here about 35%. So this is our 2 marks. Okay, so it is a 35% here. Okay, this is for question number 3. Okay, number 4. Zinc is manufactured from a zinc blende. Zinc blende is an ore which consists of mainly zinc sulfate. Okay, zinc blende is roasted in air. One of the product is zinc oxide. Okay, name the other product. Okay, now here zinc blende roasted in air. So we have here zinc oxide plus with sulfur dioxide. Okay, sulfur dioxide. So these are the equation here. And name the other product form. So we just put there sulfur dioxide as the answer. Okay, now for B, zinc oxide is then converted into zinc. Zinc oxide and coke. Coke is the carbon Okay, a source of carbon are heated in furnace. Hot air is blown into the furnace. Give 2 reasons why coke is needed. Okay, the first thing here is why coke is needed here, because carbon is much more reactive than a zinc. So it can actually reduce the zinc. You can mention the answer here, reduce zinc oxide to zinc. So if you want the equation here, we can make it zinc oxide plus with carbon, and you'll be getting here zinc and carbon monoxide. Okay, now the second reason is when a carbon is burned in the air, right, when they are forming a carbon dioxide, this one is a very exothermic. So the heat that produced in this reaction will be also used as a fuel for this process. Okay, so let me propose my answer here. So it releases heat energy when reacted with the oxygen, okay, to form carbon dioxide. Okay, so number 2, write a chemical equation for the formation of zinc in furnace. So we can mention that this is the formula that I write it here. So just copy this. We have carbon, and so here should be oxide, carbon dioxide. Okay, so here we have zinc and carbon dioxide. So make sure you do the correction here. This is supposed to be a carbon dioxide, and we balance the equation, don't forget this. And here we have CO2, so here we put 2, and zinc is 2, the rest is done. Okay, so this is our equation. Okay, so now number 3, a zinc has a melting point of 420, boiling point of 900. The temperature inside the furnace is 1200. Explain how this information shows the zinc produced inside the furnace is a gas because it's beyond the boiling point. Okay, so that is your answer here. So this is my proposed answer. Temperature inside the furnace is above the boiling point of zinc. Okay, the gaseous zinc is converted into molten zinc. Name this change of state. So this is a gas and this is a liquid. So it should be under condensation. Okay, we move to the next question here. Okay, for C, zinc react with dilute sulfuric acid to produce aqueous zinc sulfate. Right, hydrated zinc sulfate crystal made from aqueous zinc sulfate. So step 1, solid zinc added to until zinc is in excess. Okay, zinc is in excess, is separated from aqueous zinc sulfate by filtration. Okay, name the residue in step 2. Filtration. So here, remember this, when they are filtrating, and we have this, okay. So the excess zinc will be stuck here. Okay, this is the excess zinc. Example is the excess zinc, and this is called as a residue. So your answer for first one is zinc. Okay. In step 3, a saturated solution is produced. Step 3 here. Aqueous zinc sulfate is heated until solution is saturated. Describe what a saturated solution is. So this is my suggested answer. Solution containing the maximum amount of solute dissolved. Okay, this is the keyword over here. Okay, now let us move on with the next one. Okay, name two compounds, each of which react with dilute sulfuric acid to produce aqueous zinc sulfate. They are asking two compounds, so you can put here zinc oxide, zinc carbonate, or you can also put here zinc hydroxide. Alright, so these are the two other compounds, but I give you three answers. Okay, we move on with the next question. Okay, for D, when hydrated magnesium sulfate crystal are heated, they give off water. Okay, these are the equation. Students carried out an experiment to determine the value of X, the value of the water. Okay, hydrated magnesium sulfate crystal are weighed. Okay, this one it contains water. All right. Okay, step 2, it is being heated. The remaining solid was weighed again and then minus off. Okay, describe how the students can ensure that all the water is given off. You can say when the mass is constant. Let me propose my answer. Okay, here. This is a suggested answer here. Okay, heat up the substance and measure its weight and repeat the experiment until the constant weight is obtained. So there is no more water there. Alright. Okay, now let us go to the mole calculation. Okay, these are the calculation here. Okay, now we look at it in detail. In an experiment, all the water was removed from 1.2 gram of hydrated magnesium sulfate. The mass of magnesium sulfate remaining was 0.6. Okay, here is the RMM. Okay, and determine the value of X by using the following steps. So to calculate the mole, we need its weight. Remember, mass divided by its RMM. So 0.6 gram divided by 120, you are getting here 5 times 10 to the power of negative 3, or you can put there 0.005 gram. Okay, now calculate the mass of water given off. So we have to minus this. So 1.23 gram, the initial weight, and minus with the magnesium sulfate 0.6 and is 0.63 gram. Okay, to calculate the mole, we take the mass, we just follow the same formula over here. 0.63, this is 6. Okay, 0.63 divided by its RMM, which is 18. Oh, this is not given in the previous exam papers. Divided by 18, and you'll be getting here. Let me calculate this. Divided by 18, and we are getting here 0.03. Okay, 0.03, and determine the value of X. Okay, to show you how it works, please remember this one, guys. Magnesium sulfate is 0.005 gram, and the water is 0.035. Now we had to go back to the equation. Okay, we go back to the equation. Okay, let me make it bigger. Scroll again. Okay, as you can see here, this is 1, so it's 1 mole, 1 mole, 1 mole in ratio. Okay, so here we have 0.005 gram, and the water here is given 0.035. Okay, so this is X. Okay, so we have to divide this 0.035, we divide with 0.005, and we are getting here 7. So here most possibly is 7, so X is 7. Okay, so remember this ratio only can be used by using mole. So your answer here will be 7. Answer here will be 7. X is 7. Okay, this is a total mark for this question. Now we move on with the next one. Group 1 element, Group 17 element, and transition element were found in the different parts of the periodic table. So describe the trend in the reactivity of a Group 1 element. So Group 1 element, so here we have lithium, sodium, potassium, and also rubidium. So their reactivity will increase, okay, when going down the group. So you can say more reactive. Okay, so you can say it's more reactive when going down the group. So this is the keyword here, more reactive when going down the group. Okay, that's all for 5A. Now we go to 5B here. Okay, when potassium is added to water, a chemical reaction occurs. State 2 observation that can be made when potassium is added to water. Okay, so for information, when it's a group 1 with water, so here we'll be having any group 1 with water, we will be having here group 1 hydroxide. It will give you an alkaline solution, plus it will release a gas, hydrogen gas. Okay, so these are the general formula, the formula for equation group 1 with water. Okay, state 2 observation here. So what happens is you will see the flame. You will see a flame, purple color, you can say more accurately lilac flame. And observation number 2, you can see bubbles. Bubbles is due to this hydrogen gas. Okay, chemical equation, so we just can use this potassium plus with hydrogen, not hydrogen, sorry, with water. With water, it will produce potassium hydroxide with hydrogen gas. So now we need to balance this. So which is hydrogen is 3 here. We put here 2. We put here 2. Then oxygen is balanced. Potassium is balanced now. Hydrogen we have 4. Yes. So these are the equation here, guys. The balance equation. Okay. Now we move on with the next one. Excess aqueous potassium iodide is added to chlorine. So it's a potassium iodide with chlorine. So this is more to displacement process. So if you look at the group 17 here, we have fluorine, chlorine, bromine, and also iodine. So these are the most reactive. Okay, the most reactive. These are the least reactive. So your displacement here. So the chlorine will displace iodine, so you will form a potassium chloride plus with iodine. So these are the formula. So since they asked about the equation, chemical equation, we just can copy this. Potassium iodide with chlorine gas, you will have a potassium chloride and iodine. So we just have to balance this equation. So here we have 2 and 2 here, and iodine is 2. Okay, so final color of the reaction mixture. So this is, the color is a brown color. Okay, it's a brown color, and a black color is also accepted. Okay, now we go to the next one. Sodium is extracted from a sodium chloride by electrolysis. Electrolysis is, okay, so the state the meaning of term electrolysis. So here there's a certain keywords that you have to follow. Breakdown of ionic compound in molten or aqueous form by using electrical energy. So this is the definition for electrolysis. Okay, now we look at here. State what must be done to sodium chloride before it can be electrolyzed to produce sodium. Okay, so now if you notice the question, it is in a solid state. Okay, this one currently is in solid state. So we need to heat it up. Heat up sodium chloride until it melts, or you can use other word, until it is in until it reach to a molten state. Okay, now write an ionic half equation for change that occurs at the cathode. Okay, now when you're having this one, we have 2 ions. One is a sodium, another one is a chloride. This one will be attracted to the anode, which is the positive rod, and this one will be attracted to the cathode, which is the negative rod. So here we'll be having, you will accept electrons and produce sodium. Okay, so now we move to the next question. Okay, chromium is a transition element. So it has all these properties. Okay, use this information to give the 2 properties of chromium which are different from properties of group 1 elements such as sodium. So let us go through one by one here. Sodium. Okay, you can also mention here the sodium, it has only one oxidation state. Okay, however, look at this chromium, they have 2 oxidation state. One is a chromium 2 positive, another is a chromium 3 positive. One of your answer here. And chromium, it has a very high melting point. However, sodium, it has a average low melting point. And the other comparisons here, it has okay, now all the transition element, it will behave as a catalyst. However, sodium cannot behave as a catalyst as it is a reactive metal. Okay, so let me propose my answer here. So I have proposed my answer here, which is it forms a variable oxidation state, and it also form a colorful solution. And you have a lot more answers, like chromium has a higher melting point, and also it behaves as a catalyst. Okay, you can also use these answers. Now number 2, use this information to give 2 properties of chromium which are similar to properties of a group 1 sodium. So both of them, they do conduct electricity, okay, they do conduct electricity. And the next one, they do also form, okay, look at here, this part, okay, many chromium compounds are soluble in water. However, sodium also soluble in water. So you can say both of them, they are soluble in water. Okay, as your answer. So this is a 2 marks. And total marks for this question is 16 marks. Okay, now we move on with the next question. Okay, number 6. A carboxylic acid and ester are structural isomers. State the meaning of the term structural isomers. So they do have a same formula, okay, molecular formula, but they have a different structural formula. Okay, you can see this compound with the same molecular formula but a different structural formula. Okay, that's for your 2 marks. Okay, let us scroll down to the next question. Okay, draw the structure of a carboxylic acid and ester which both contains 2 carbon atoms. Show all atoms and all bonds. Okay, carboxylic acid, when they have two carbon atoms, so remember their formula is this is their molecular formula, COOH. So when it's 2, you have to minus 1 because you already have another carbon here. So it's C, so the formula here will be CH3COOH. Okay, so this is your other structure, and you have a C. This is called as ethanoic acid. Ethanoic acid. Okay, for the ester which has a 2 carbon. So remember, ester is a combination of a carboxylic acid and also alcohol. So let me write down the formula here. The first part is from the carboxylic acid. Okay, and then the second part here will be coming from the alcohol. All right. So since they have 2 carbons, so what we can do now, we can make here C from the acid side, and we have 1 H here. Then another carbon will go to the alcohol part, which is C1, and you have another 3 more bondings. So the naming part for the ester will be from the alcohol first. This is methanol. All right, this is from methanol. So you have a methyl from here, methyl from here, this part, and the second part here will be coming from a carboxylic acid, which is a methanoate. And this one is a methanoic acid. It is coming from methanoic acid, this one. So this is the name. Okay, so here we have a 4 marks here. Okay, now we move on with the next one. Okay, so a part of a polyester chain is shown. This polyester is made from 1 monomer. On the diagram, draw a ring around 1 unit of a polymer that is repeated. So you can see these are the things that are repeated. Okay, so okay, polymerization, they have two types. They are asking for name the type of polymerization. One is they have an addition, and then they will have a condensation. So for this type, it is certainly is a condensation type. Condensation means both of them will be combining with the loss of water. Okay, so we move on with the next one, number 3. Complete the diagram to show. Okay, complete the diagram to show the structure of monomer used to produce this polyester. Show all the atoms and the bonds. So here we just continue. We have this acid and we have here OH. Okay. Okay, now we come to the second part here, this part. Okay. A polyamide is made from two monomers. So which is this? Okay, to explain to you further, so let me explain to you at this part here. Okay, now acid. So here we have a double bond, okay, hydrogen. So here we have OH. Okay, since it is under condensation, so what happens here is they will combine to form the water. So here the OH and one of the H, okay, one of the H here, and let's say I just draw another one more H. Okay, this H and this OH will combine to form the water. So what happened now? Here they have nitrogen and hydrogen for both of these. Same goes to here at this side. Nitrogen and hydrogen. Okay. So now the next one here will be CO. So carbon and oxygen, here we have a double bond. So you can draw upside down. Okay, they'll have a bonding here. And C double bond O. So these are the complete structure. So you can even erase this part. Okay, it will look like more proper. Okay, so these are the answers for this. Okay, now look at here this part. Okay, naturally occurring polyamide constituent of food. State the name given to naturally occurring polymers. So here will be under protein. Why protein? Because they do contain amino acid. Okay, and name the monomer which form naturally occurring polyamides, and you can write down the answer over here, amino acid. Okay, so this is the end of the question. So I hope you enjoy the video. Okay, please comment below for the questions that you don't understand, so I will reply to you. And please subscribe and like the video. Thank you very much, guys. All the best for your revisions.